domain, and range. Our objective is at the end of the lesson, you are going to determine if the given relation is a function or not and identify the domain and range given representations like ordered pair and mapping diagram. So let's proceed. Let's first define what is a relation. A relation is a sets of values of x and y, or the input and output, or what we call x coordinates and y coordinates. So on a relation, we can represent the relations as an ordered pair and mapping diagram.
Domain are all the possible value of your x, and range are all the possible values of y. It says, check it out. Example number 1, give the domain and range for the relations shown in the graph. As we write them in ordered pairs, now we can now easily identify the domain and the range. So the domain are all the red numbers that you can see on the sets of ordered pairs. So let us write domain. Okay, domain. In writing the domain and the range, take note, if they are written in an ordered pair, we will use a bracket. What is a bracket? Okay, this is a sample of bracket. So again, okay, take note. In writing the domain and range, aside from using a bracket, we need to write them first in a proper order from least to highest. Okay, so in here, the least number is -2, followed by -1, followed by 0, because as I mentioned a while ago, all value of x. In an ordered pair, x and then y. So x first. And then we have +1, +2, and +3. Right? So those are all the value of the domain. Next, let us use a blue font for the range. Range are all possible value of your y. So we're focusing on the second value or second numbers because y are what we call the range. Okay, so again, we'll use a bracket and then from least to highest. So lowest number is a -3, followed by -2, followed by -1, and then 0, +1, and then +2. Those are all the range on that set of ordered pairs. For the example number 2, again, this is a table of values and a set of ordered pairs. To write this table of values in a set of ordered pairs, so you'll just write them like 0, 2, that is the first one, 3, 4, -3, -2, and then 2, 4. After writing them in a set of ordered pairs, now we can easily identify the domain and range. Again, take note. Take note that the x values are the domain. So the domain are these numbers. So let us write first all the domains. So the domains, we will use bracket. We'll start with the least number or lowest number. Negative number comes first. So we have -3, followed by 0, +2, and then +3. So those are the domains. Okay, next. Again, you can see them on the x value, 0, 0, 3, -3, and 2. But I just write them in an order, proper order from least to highest. Next, let us have the range. So the range, it's just the same. The values of the y values. Focus on the second number, the purple numbers. Okay, we have +2, +4, -2, and +4. Okay, but we will write them first from least to highest. So we will use bracket, start with -2, +2, and 4. Means we have 2, 4. How come you just write it once? We can write it once only since we all know that one of the that range that 4 is considered as a range. So if you can see a repeated number, you may just write it once. Okay, any more questions? On the table, look at all the y values. We have 2, 4, negative 2, and 4. Why did we start with the negative 2? Because that is the lowest number for the range. Least to highest. So let us now proceed to a relation. Let us define first a relation. A relation shows a relationship between two values. A relation, what is, can you give me an example of relation in real world scenario? Students and teachers, that a relation? Yes, because we have two values, teacher and student, that is a relation. Paper and pen, is that a relation? Yes, because we have paper and pen as two values. Those are real world scenarios, okay, or examples. Relations represent a two values of the x and y in which we call the domain and the range, okay? So however, not all relations are functions. So we have what the word function. Again, I repeat, not all relations are functions. So miss, how can we tell if the relation is a function or not? As I repeat, miss, how can we tell if the given relation is a function? From the definition itself, it says in here that each input has only one output. Take note, the input is the x value or the domain, and the output is the y values or the range. So that means there must no repetition number on your x values. Because if there is a repetitive number on your x values, that is not considered as a function. Okay? So we have a given example of functions in here. So we have what they call one-to-one or many-to-one. So let us check why it is considered as a function. 1 corresponds 3, 2 corresponds 4, 3 corresponds 5, and 4 corresponds 6. So there is no repetition. There is no repetition on your x values or domain. So that means it is considered as function because we didn't repeat the x values more than 1. Okay? Next, we have many to 1. 0, again, these are the domain. Let me just write domain. And then this one are the range. 0 corresponds 0, 1 corresponds 1, 2 corresponds 4, negative 2 corresponds 4. Miss, we use 4 twice, but it is under the range. Okay, again, to identify if the given relation is a function, focus on the domain. Focus only on the domain. So if there is a repetitive number on the range, it's fine. It is still considered as a function. However, if there is a repetitive number on your x values, that is not considered as a function. Take note of that. Okay, so this one is still considered as a function. How about those non-function? We have a given example on the right side of your screen. 1 corresponds 1, 9 corresponds 3, and negative 3. So we use positive 9 twice for positive 3 and negative 3. That is why it is not considered as a not function. Take note of that. Okay, next example, many to many. 1 corresponds 4, so it's just fine. 2 corresponds 4, it's still okay. However, 3 corresponds 5 and 6. So we use 3 twice for your y values. So this one is not a function. Does it make sense? Okay, sounds good. So take note of that, okay? Focus only on the x values when you determine if the given is a function or not function. So let's proceed on the next slide. Example number 3. Answer the following given ordered pairs below. So we have 8, 2, 6, 3, 8, 1, 0, negative 2, and 3, 5. Let us first identify what are the domains. So I will use red font for the domain. Again, we'll use bracket. And then um, least to lowest. So I just cancel out all the x values. So the least x value is 0, followed by 3, followed by 6, and then we have 2, 8. So I will just highlight the 8. We have 2, 8. That means we use 8 twice. So if you use the x value more than once, is it a function or not? Good job. It is not a function. Relation a function? Not. So the answer is no, because positive 8 on the domain use twice for the range. Okay, question about that? If there's no question, we'll proceed. What are the range? So for the range, these are the second value or the y values. The range are -2, 1, 2, 3, and 5. An example number 4. Answer the following given order pairs below. So first, we're going to identify all the domains. So we'll use red font for the domain. So we have 5, 6, 8, 0, and 3. Okay? So from least to highest, we'll start with 0, followed by, so we need to be careful. I will just cancel out what I have written so that I will not get confused. Then +3, followed by +5, followed by 6, and then +8. So those are the domains. Next, let us check what are the range. So for the range, these are the second value. I will encircle the range and then write them on the proper order. So we have -2. Oopsie, we used -2 twice on the range. But as I mentioned, if you use repetitive number on the range, it will not affect if it is a function or not. So it's still fine as much as there is no repetitive number on the domain. So concentrate on the domain when you identify if the given relation is a function or not. Okay, so we have -2 followed by +1 followed by 3 and then 5. So I repeat, if there's a repetitive number on the range, it's still fine. It is still considered as a function as much as there's no repetitive number on the domain. Is the relation is a function or not? It is a function. So we are going to write yes. Because good job. Because there is no repeating number on the domain. Repeating number on the domain. Okay. So hope you've learned from examples 3 and 4. Now, as we always believe that there's no retention in learning in math if you will not apply what you have learned. So please answer slide 5 and slide 6. Example number 5 and 6. And also the check your understanding 1 through 5.